Last week we learned about a lot of kinds of short channel effects, but today I'm going to explain about punch through. Punch through happens because as device getting smaller, the channel also getting shorter. That means even though the bias in drain is not strong, the channel is so short that some kind of depletion in the body makes the channel. So it means that even if the device is off state, that means when the voltage is even not applied at the gate terminal, it's still the current still flow in the body through the path that depletion region made. So that is what the punch through is, and there's some solution, but I'm gonna tell SOI. SOI means silicon insulator, which means put insulator in the body to prevent from the depletion. So the mechanism is that easy, but there's some problems. The thing is that first of all, SOI is pretty expensive. Cost is one of the most important components in the field of semiconductor, I guess. So the cost is the biggest disadvantage of this SOI. The second one is self-heating. When carrier flows, there's some collisions between carriers and lattice, and lattice kind of getting vibrated, and that means thermal energy. But in the normal case, when the body is made of silicon, the heatings can be synced. But in this case, when we put the insulator in it, there's no holes or way to sync well, so that makes thermal energy inside. That means that make mobility lower. Lower, and by Ohm's law, when the mobility gets lower, the current also gets pretty low. That means when the device is on state, the current is pretty low. That means that doesn't work. That works poor. So I think these two kinds of problem is indicates that why people don't use SOI method these days. I think that this is about it for last week.